Here's a problem about a phone tree. A support line starts the tree to recruit volunteers. In round 1, just 5 new volunteers join. In each new round after that, the number of new volunteers is 3 times the round before. It triples. The tree has a rule, though. It stops before any round would add more than 1,000 new volunteers. The question, how many new volunteers join altogether? Pause the video and try it. 2 parts to think about. First, when does the tree have to stop? List the rounds out. 5, then triple, triple, triple. And second, once you know the rounds, how do you add them up cleverly? Pause now. I'll wait. Let's tackle idea 1. Each new round triples. So the counts go 5, 15, 45, 135, 405, and then 1,215. When does the rule say the tree must stop? The tree stops just before round 6, because round 6 would add 1,215 volunteers, more than 1,000. So the last allowed round is round 5, with 405. That gives us 5 rounds in total. Now we need the sum. 5 plus 15 plus 45 plus 135 plus 405. Now idea 2. Each term triples the one before. That's the same kind of structure as the bookshelf problem, but multiplying instead of adding. Remember how we wrote the sum forwards and backwards, then added? Here we'll do the geometric version. What if we multiply the whole sum by 3, then subtract? Watch what happens. Write S equals 5 plus 15 plus 45 plus 135 plus 405. Now multiply every term by 3. That gives 3S equals 15 plus 45 plus 135 plus 405 plus 1,215. Look, almost every term in the middle appears in both lines. Subtract the first line from the second. Everything in the middle cancels. We're left with 3S minus S equals 1,215 minus 5. That's 2S equals 1,210, so S equals 605. 605 new volunteers join the support line in all. The phone tree, 5 rounds long, recruits 605 people. And here is the big lesson. Watch how the same idiom solved both kinds of problems. With an arithmetic sum, numbers growing by adding, we wrote the sum forwards and backwards, then added. The middle pairs all matched. With a geometric sum, numbers growing by multiplying, we wrote the sum once, then multiplied by the ratio, then subtracted. The middle terms all canceled. Same idea, different operation. Write the sum a second way, then combine. And the messy middle disappears. That's mathematical beauty. Learn, compete, and win at competitivekids.org.